So good evening everyone. Welcome to this interactive session week 8 on the course on Introduction to Multimodal Urban Transportation Systems. So the course instructor is Dr. Arpapal Goswami and myself Suman Ganguly. I am a PMR Research Scholar at IIT Kharagpur. So let's start the session. So in this course or in this week I have designed some 9 questions, and it's a mix of numerical as well as the theoretical questions, right? So the first question is, which of the following is not a NMT supportive principle, right? So there are 4 options. First one is mixed use, then the parking management, third one is universal accessibility, fourth one is transit priority. So which one of the following is not a NMT supportive principle? So NMT is non-motorized transportation, right? So in case of non-motorized transportation, there are generally 2 kinds of principles. So one is NMT guideline principles and second one is NMT supportive principles. So if you remember the NMT guidelines principle, there are 10 factors, right? So basically what it means that, so if you want to plan for a NMT facility, or you so what are the guidelines that needs to be followed? What should be the guidelines? So then there were 10 principal factors, right? So first is interconnected NMT network. So your NMT network should be interconnected. Then your bicycle friendliness, then your walking friendliness or walkability. Then it comes to the comfort, right? Then the safety, security and all, right? So those are called the NMT guidelines that you should follow before you basically design your NMT on a road. So then what are the supporting principles? So if you have a NMT facility that you develop, so it should have some perspective that it should support some other kinds of things also, right? It is not an isolated thing, it is an integrated thing rather. So what are the NMT supportive principles? So supportive principles are which? So here the question is which one of the following is not an NMT supportive? So if you see mixed use or mixed land use, so suppose if you have an NMT facility and if your home is nearby, then you have an NMT facility and then you park a vehicle, then you use a public transportation system or transit priority system if it is there. So it's a kind of interlinked, right? So it should support those kind of facilities. But in case of universal accessibility, which means that everyone starting from children, then the older people, even the disabled people, they should actually, or I should say specially able people, actually they should be able to use the NMT facility, but that's a part of NMT guidance factors, not the this. So here these are not the factors, right? So then your answer would be C. So now we can go to the next question. So this is the next question. It is, there is a picture that has been given. So the question is, it is an example of which of the NMT guidance principle. So we have 10 NMT guidance principle. So this picture depicts which kind of or which form of the NMT guidance principle. So is it showing interconnected NMT road network? So what is the interconnected NMT road network? So that it's a continuous road network. It should not be discontinuous, right? So that's called the interconnected. So is it the walkability? Because here also in the image we have some basically footpaths so that people can walk, right? And then the protection from encroachment. also the picture also depicts that the encroachment is not there. Right? Here if you see, the encroachment is not there. So it's an example of which kinds of NMT guidance principle. So actually I know it is rather very easy. So actually this kinds of thing is called the complete street. This is called complete streets. So complete street means it is consist of, it's an integrated system, consists of all kind of users. So a road is not only used by motorists but also used by NMT facilities, and NMT means not only cycles, bicycles, but also the cycle rickshaws, then the walking also it has been included, even includes specially abled facilities and those things. So it's called a complete street. So then the third question is, which of the following statements is false for NMT wayfinding? So what is the NMT wayfinding? NMT wayfinding is basically, suppose you are using a bicycle, and suppose you are using a bicycle as a mode of NMT and you want to go from point A to B. So then you may not know the route, right? So then your wayfinding app or wayfinding maybe in the web form, it is actually giving you the guidance so that you can reach from point A to B. So now the question is, which of the following statements is false? So first is, promote NMT usage among tourists. So suppose you are a tourist and you went to a new place, so then it is very difficult to use the NMT facility. We can use any public transport maybe, but how you can use the NMT facility without proper wayfinding? Otherwise you need some guidance from someone, right? So actually it's true that you need, like, it promotes the NMT usage, because if I have an app then I will be confident, right? So nowadays what happened usually, when people are going anywhere in the country or outside the country, but actually they are just searching that, okay, this is the particular location, how to go or how to reach that particular destination with the use of Google Maps. Although it is not 100% accurate, but it is a fairly accurate phenomenon, right? So it is providing, actually it is promoting NMT usage among tourists. So then the B option is providing easy and legible navigation. Yes, it will provide an easy and legible navigation, right? So then the third one is provides uninterrupted non-motorized or NMT mobility and brings in a sense of order. So suppose you have a NMT wayfinding app, or maybe in the form of web, then is it guaranteed that it will give you a uninterrupted non-motorized mobility? Because uninterrupted means it is not interrupted, it is a continuous thing. So actually it may not be continuous, because it depends on the roads, existing road design, right? So if you have an intersection, if you have some part of your route that is not usually, like, it is intersection is there, so it is not an uninterrupted facility, right? It's an interrupted cycle track. If we consider it's a cycle track, then it is so it is a false statement, right? So then the D is assist the users in navigation and improve the sense of place. Obviously it will assist the users in navigation, right? So the false statement is this, right? So now you can try to answer what is the following figure A, which is shown in the figure, what it denotes. Is it denotes an tactile paving? Is it denotes a ladder pattern of movements? Or is it okay, desired line? So like, what is desired line? Do you know what is desired line? Why it is called desired line? So basically, if you are familiar with the traffic, so we generally what we do in the roads or on the roads, it is called an actually no. That's why I asked the question, because it is not the shortest path. That's why it is a desired line. It may not be true, right? It's a shortest path. That's a separate thing. But I have asked that what is desired line. People are taking that route because it's shortest. It is having a tendency to go about on that route. But suppose it's a dry situation. Suppose it's a rainy season and there are muds along this path. Then do you think that people will use that route? Probably not. People will take that turn and go about it. Right? So it is not regarding the only the shortest path. So desire line, generally in the traffic, what we do an origin destination survey. So suppose you are coming from your home and you are going office. Your office is at a point B and you are coming from at a point A. And each individual people are going from a certain place and going towards at certain place, maybe work or something. So if you for a particular area, if you know that where the people are going at a particular hour or for a particular day, so then you will get kind of this this kind of pattern, right? So this is called actually desire lens, where people have the desire to. So now it is a numerical one. So calculate the time gap for a platoon of 40 school children. They are walking 5 in a row, where the consecutive time between those rows is 2 seconds, and the width of that crossing section, means the road width, is 8 meter, and the speed of walking is 1.1 meter per second, and there is a startup loss time as 3 seconds. So then you need to calculate time gap. So you calculate the time gap. So if you know the formula, it is very easy to calculate, right? So what is the time gap formula? Time gap formula is the width of road by your speed of pedestrian plus your consecutive TC into n minus 1. N is what? N is the gap between two consecutive pairs or rows, and then your startup loss time. So if you see, everything is given. Your width is what? Width is 8 meter, right? So this is 8. Your speed has been given as 1.1. Your startup loss time is 3. Then your consecutive time is 2. Then your n has been calculated by 40 by 5. 5 in a row means 40 school children. 5 in a row means there are 8 such strips that the people are walking, right? So that is 8. So now it is called the time gap, right? You are saying 24.t, I have no idea, but let me first give you a brief that how this formula came. So suppose this is the width of the road, 8 meter here. This a pedestrian has to cross from here, right? So one pedestrian, how much time it will take to cross? 8 by velocity. Velocity is suppose 1.1 meter. So this is the time taken by one pedestrian to cross the road. Right? Now suppose after this pedestrian cross the road, there will be consecutively another one will cross the road. Right? So if it cross the road like this, so and within a gap of 2 seconds there is another pedestrian. He will also cross the road. Suppose there are 40 people. Right? So then you need to add plus 2, again add plus 2 if their gap is, suppose if you have a 4 pedestrian, so your total time is plus 2 plus 2 plus 2 plus this, right? So 4 pedestrian, 1 2 3 4. So this is 2 seconds, this is 2 seconds, this is 2 seconds. 2, 2, 2. So if you have 4 pedestrians, how many number of gaps you required? You required 3. So that's why it is called n minus 1, right? So now if you see that it's a 8 meter long road, or the width of the road. Suppose now you have a 5 row. 5 row means this is a row, this is a row, 5 in a row, 5 in a row, like this 8. So now you need some gaps, or 7 gaps you need, right? And you need to add the 2, because 7 into 2 plus 14, and plus you need to add for one pedestrian what is the time. You add this time. So then another additional is the startup time. So whenever pedestrian has been given the green signal, it will consume some time before it react, right? So if I saw, then I will react. So it is called the startup time. It will be added also. So now if I calculate here, you said that I think 24.3. So if I calculate now, so I think the concept is clear how these 3 terms came, right? Because that is very important. Formula is very easy, but why that came formula, that sometimes that intuition is good if you know that intuition. So suppose 8 by 1.1 plus TC is 2 into 7, 14 plus your 3. It is 24.27. So this is the answer. So now you have a road 20 meter wide, right? Needs a pedestrian crossing with refuge island. So you have a road of 20 meter width. Now it is regularly crossed by a platoon of 30 school children, 6 in a row, right? These children cross with a consecutive time of 3 seconds, startup time 3.5 seconds, walking speed has been given as to 1.1 second. Then to increase the comfort, suppose your pedestrian signal is 30 seconds. Now you calculate and tell me what is the number and position of the refuge island that you need to cross a particular section of road. Your road width is 20 meter. Now you tell me your pedestrian green time or time gap has been given as 30 seconds. And then rest of the everything is given, so you can calculate your width, that that number of pedestrians, how much time at time 30 seconds, what is the amount of road width that actually they are crossing. So then based on that you need to decide your number and position of refuge island, right? So you calculate and tell me, because I think it is very easy to calculate. 4 into 3 plus 3.5. So okay, then your 1.1 equal to 30. So then 30 minus answer is this into 1.1. Tell me what is the width. I have already calculated. Now you tell me what is the, first you tell me what is the length or width of the road or length of this pedestrian crosswalk that actually pedestrian will be able to cross at time of 30 seconds. but the road width is 20 meter and the platoon of children is 30. So what could be that scenario? So I think you know that formula is W by 1.1 plus your n is 6 into 6, 30 by 6, 5 matlab 4, right? 4 into your consecutive time is 3 plus your 3.5. It is equal to 30 seconds. So now if you calculate the width, so your width is 15 point, I think 5 or 9.5, something like that. So now you have a road of 20 meter. So your width was 20 meter. This is 20 meter. And your pedestrian will be cross up to, yes, 15.95 or 16 close to. So now you have left a 4 meter width to cross. So what should we do? How many number of island would you provide? So what is a refuge island? Refuge island means, so in the middle there is an island, so you go and you stop there and then you go for the other section of the road, right? So generally a 20 meter road means it's a wide road. It may be a 4-lane carriageway, so there are 2 lanes here, 2 lanes on the other side. But here the problem is already they have crossed 16 meter. So should we provide a refuge island for only 4 meter? That's a question. What should we do? What would be a rationale to do in the mid? No, then in the mid, if you are saying in the mid, so then here they are crossing 16 meter. They will able to cross, right? And actually in the middle means you need 10 meter. Then your this 6 meter is wastage because there are green time is available, but still no one is crossing it, right? Your additional green time will be available. We may reduce the green time. Okay, then the question is, if you want to do it for 10 meter, how much green time should we need? Now it is crossing 15.5. Approx 7 seconds. You did some linear interpolation, right? Yes, but still if I want to do it, how do I do it? Already I know everything, right? So it can be calculated actually, but it is very easy to calculate, right? So now the next is, a bicycle is to make a safe turn without skidding, obviously, at a corner with a turning radius of 18 meters. What is the maximum speed at which the bicycle can turn? What is the Vmax? Everything is given. Your coefficient of friction is 0.25, your theta is 0.25 degree, and your acceleration due to gravity is 9.81 meter per second square. Right? Turning radius has been given as 18. So what would be the maximum speed at which the bicycle can turn? I will wait first so that you will be able to do something and then tell me, and then I will do that. And also it is not necessary also to remember the formula because it's very easy. If you know how the force and how to basically, if you are from science background and if you remember in the class, I think 10th 11, we have this force, how to divide it, the force into the segments like in cos theta sin theta, and then how to calculate. So it is basically based on that concept. In the physics we actually in the 11th standards only we read it, right? So it is not very difficult to calculate, it is relatively easy rather. So suppose if you, this is a cycle and it is want to turn right like this, right? So now the cycle has its weight as W. W is the self weight. So it is what? Mass into gravity, acceleration due to gravity. And suppose we are standing vertical, so there will be an reaction force R. So why there will be a reaction force? Based on the Newton's principle, right? So every action will have a equal and opposite reaction. So if you have this weight here, so you have an equal and opposite reaction on the opposite side, because that's how equilibrium works. So now if we want to take a turn like this, this cycle, so then your angle with the vertical is theta. So your closer value would be sin theta, because sin 90 value is 1, but whereas cos 0 value is 1. So whatever your least angle is, that will be cos theta component, right? Because suppose you want to negotiate a curve like this, so it will not be like and 45 and more than 45, it should be less than 45, otherwise you will skid, right? Or you will fall maybe. So that's why it is cos theta, and here it will be sin theta. It is the sine component, the horizontal. And already I said this is the weight. This weight is reacting like this. So if you see, if you are turning like this, so here there are two forces. One is the friction of the tires, that is called F. Another one is your centripetal force. So any object, if you are turning like this, so your centripetal force is balancing you, right? Because you have an centrifugal force acting right here. So it's the opposite, that the reaction force, it is called the centripetal force, that is called mv square by r. So now your equation is, your left is mv square by r plus your F. It is equal to what? Your reaction force into sin theta. So this is for horizontal distribution of forces. Right? What about the vertical? Vertical is very straightforward. Your vertical component is upside is r cos theta, and your downward component is W, that is called mg. So now if you just divide the equation 1 with equation 2, right, you get tan theta. Right? So you will get tan theta equal to what? You will get tan theta equal to this by this. So then if you calculate, you will get your maximum speed as the final formula, R into G tan theta minus friction component into G, or you can say Rg tan theta minus that. So now you calculate and tell me the answer. I will also calculate, but you should also calculate. So your theta, okay. So tan 25 Rg common tan 25 minus Fs. So then what is the Fs value? Fs value is 0.25, right? So then 0.216. So if it is a 0.216 into r into g, 9.81 in meters, and r is how much? 80 meters. So then this is 13 point and root of answer is 6.18 will be your maximum speed in meter per second, because everything is in meter per second. So is it okay? Are you able to calculate, or do you have something to ask? Tell me. You should calculate and check whether I have done it correct or not, right? Sometimes there could be calculation mistakes, right? But I think I have done it correct, but still you are getting 9. Okay, then I should recheck, right? So the formula is root over rg into tan theta minus fs. You can calculate also, right? Once you can calculate also, we will come to an general agreement, right? Because answer should be 1. It is a trivial solution, right? So 1025, right? 1025 minus fs is 0.25. Then into g, 9.81. Okay, then into r is 18. Okay. So tell me, I got the same value, but I am just thinking. So how do you get say different value? Okay, that is okay. 6.08 and 18 are close. So that is okay. So now okay. So let me go to the next question. Right. So now we have a tall building which is located 20 meter from the straight line of sight of a car. So I have not given you the picture, but you can imagine and draw it. And 40 meter from the straight line of sight of a bicycle. So imagine this is an intersection. So at one approach there is a bicyclist, and another approach there is a car, right? They are approaching like this. So determine the side distance available to the bicycle. So what is the side distance available to the bicycle to reach the intersection, right? If the car at C is approaching the unsignalized intersection, that's what I said, that they are approaching the unsignalized intersection, which is 100 meter away. So maybe I should try to draw the diagram. So this is the intersection, and imagine this is the corner of a tall building. Imagine like this. So now 20 meter of a car. So this is the car, and this is the tall building T, and the corner of a tall building is this. I did not draw the buildings, but imagine this is the point of the building. So now this value is 20 meter, 20, and if you have a bicycle here, it's a bicycle, right? It's in bicycle. And your bicycle distance is what? 40 meter from this is 40 meters bicycle, and your unsignalized intersection is 100 meters away. So suppose your unsignalized intersection is 100 meters, right? Now the question is, what is this to this, how much? This is 40 meter, we know, but we don't know this point, right? Side distance, yes. Actually, this is called stopping side distance. If you have read the geometric design of highways, it is called the stopping side distance. That is, what is the side distance available, and is that distance enough for me to stop the vehicle, to avoid the collision of the vehicle with the other vehicle. That is called the stopping side distance, or here it is called the side distance. So now tell me, what would be the answer? I think here you are saying 33.33. Okay. I don't know, I need to calculate. I will wait for another answer, then I will see. So your pick is 100. Tell me. Can you recheck your calculation once? Can you recheck, whoever is said 33.33? Can you recheck once? I think it is not 33.33. Recheck and you do it also. Try to see, because I am not getting the same answer. I have also calculated. I am calculating once again. You should also try to calculate. Did you calculate it? So it is not 30.33.33. It is not. So let me draw a triangle here. Suppose this is the point C, this is the point A, and this is the tall building point. Here tall building is there. So from car to tall building, this distance has been given as 20 meters, and this total has been given as 100. So if it is 20 and this is 100, this line is 80, right? And from tall building to this distance has been given as 40. So now if you have a similar triangle, this and the big one, so big one, the horizontal is 100 and the vertical is, if suppose this is x, this is unknown, so this is x plus 40, and for this smaller, this triangle, it is 80 because this is 20, so this is 80 by 40, 80 by 40 means 2, so 2x plus 80 is equal to 100. X is equal to how much? 10. So what is the side distance then? 40 is there and x is 10, 50 meters. The answer will be 50 meters. Did you get the, did you understand? Can you respond that did you understand or not? Okay. Then this is not from this week, this is from the previous week. So someone has some doubt, as I was informed, that there is some problem that he or she may not be able to grasp what is happening here. So it is a question that is given in the week 6, that is solved in the course material itself, right? So here dp is the pedestrian wait time and it is related to the crosswalk and the pedestrian level of service. So based on the pedestrian wait time at signals, actually it is calculated, right? So now if you see, this is C is cycle time, G is green time, C is cycle time. So now if you have this kind of road, suppose, so this is suppose a major road. So now pedestrian is waiting here and he wants to cross here, right? Here to here. So now here if you see the formula, if your G is higher, then your C minus G is lower. So if your C minus G is lower, your pedestrian wait time is lower, right? So your G higher means more green time leads to less waiting time, means more time for a pedestrian to cross the road, right? So now see here, if I want to cross, so here the vehicular signal should be red, right? And this signal may be green. Then only I will be able to cross the road here. So now if I want to calculate the waiting time for here, the green time is for the, not the major road, it is major road, it is for the minor road actually. So whenever you are calculating major of dp, then you should take G minor, not the major, right? And vice versa. And also there was a mistake in the formula itself. So it is not 2C, it is only C. So if you see whatever the results are there, those results are okay for this problem. But one problem is, there was the formula is 0.5 into c minus g the square by 2c, but it is not 2c. Based on the HCM I have rechecked, it is c only. That's why the values were twice the value. What is the actual value? That is the twice value, right? So it will be c. Another thing is, for major road they have also wrote it major, but it should be for major road pedestrian weight, it should be g would be minor. They have taken the value as minor, but maybe the writing is they have written is as g major, so it should be g minor. So I don't know who has that doubt, but I think that has been clarified now, right? So then that options are correct, and the whatever means the values are there but correct, but you need to change your formula, because if you are using 2c, then you will get the half of the answer, and your g should be g minor if you are using for a major, and if you are calculating pedestrian weight for a minor street, you should use the green of the major street, right? So that's what the clarification is. I think it is somewhat now clarified. Rest of the things you can calculate, and you can see what is the level of service, right? So this is all for today. So now if you have anything to ask regarding any course material or today's solution, you can ask before we wrap up today, right? So you respond if you need something more for today's session. Otherwise, we can end the session, right? Please respond if you need, or if you have some doubts or need some clarification, and if not also you can say that it is okay. Please respond. I will wait for a couple of seconds because I am not getting any replies from you. So I hope it is clarified whatever your doubts are. So we will meet in the next week as week 9 of the course. So for today we can finish the session. Okay, bye.